Hello everyone. So we will solve the third problem of this contest, LeetCode Weekly Contest 506. The problem is maximize sum of device rating. The problem is very not very simple. It is easy, right? But the English of the problem is very complicated, right? So first let's read the problem statement. I will then explain the problem statement to you in simple terms, in simplest term possible, and then you can derive a solution all by yourself if I give you few hints, right? So let's jump to the problem statement, and before that we have a Discord channel. If you want to join, you can definitely join that as well. And if you found this video helpful, please do give a like and a subscribe as well, right? So let's see the problem statement. So the states that you are given a 2D integer array units of size m cross n, where units of ij represents the capacity of the jth unit in ith device. Each device contain exactly n units, so every device will have n units, right? The rating of a device is the minimum capacity among all its unit, right? So what does this mean? Till now the problem statement means, let's say you had 2 4 1 2 1 3 6 as your values. The rating of this unit will be 1, right? So the rating is the minimum capacity among all its unit, right? You may perform the following operation any number of times, including 0. It's your wish. You choose a device I that has not been used as a source before, and you will remove exactly 1 unit from the device and add it to any different device. Okay. Then mark device I as used so that it cannot be used in future again as a source, right? You need to return the maximum possible sum of all the ratings of all devices after any number of such operations. I know the problem is a bit clumsy. What do the problem state? I am explaining you in simplest term possible, right? So the problem states that you will be given an array, right? A 2D vector, some that looks something like this. Every element will have exactly n elements, right? Okay. And every element has some values in it, right? The problem asks you that you can pick any I. Let's say we picked this I, right? After picking this array, let's say you can pick any element of your choice. Let's say this had x1 x2 x3 and x4, right? Let's say you picked x2, and you will pick this x2 and you can place it anywhere. Let's place it in this vector, right? So this vector will have an additional x2, right? And this is it. Okay. Again, you can pick any vector. Let's call y1 y2 y3 y4. You can pick y3 and place that element to this vector. Again, any vector of your choice, you can place that element here as well. It's of your wish, right? So let's say we are placing it, let's say here, right? Y3. Y3 gets added to this vector. There can be Z1, Z2, Z3, and Z4. And then Y3 is also added to this, and Y3 gets deleted from this. Similarly, X2 is not in this vector anymore, right? The problem asks you that after you have done any number of operations, right? Let's say one more thing. If you have chosen X2 from this, now you can't choose anything from this vector. You can place, see, you can't remove elements from one vector, one array rather, multiple times. Means you can do it only once. You can't remove elements from one vector multiple times, but you can add elements to a vector multiple times. Add elements to a vector or array multiple times, right? What does this mean? This y3 could be placed easily in this vector and there won't be any issue with it, right? So the problem statement might be clear to you, yes or no? So now the problem becomes easy, right? So they are saying find the rating sum, right? What is the rating sum? Rating sum is the minimum value of all the arrays which you had, right? Let's say this array had minimum, let's say y2. This array had x1, let's say this had x4, and let's say this had x2, right? So the ultimate will be x2 plus z4 plus x1 plus y2, anything, it could be anything, but ultimately you need to return this sum, and this sum should be as maximum as possible, right? At first glance this might be looking like, wow, the problem is very very hard, right? Let's look at a few test case and then I will give you a wow solution, right? The problem has a wow moment, we will look at that as well. So 1 2 3 4 5 6, right? 1 2 3 and 4 5 6, right? Okay, so the best possible answer that we can form is, if we pick this 4 and place it at this array, the array becomes 1 2 3 4 and 5 6, and this has a minimum 5, this has a minimum 1, the total sum becomes 5 plus 1, which is 6, which is the minimum possible answer which you can get, right? You can try out all possible ways. This will 6 will be the minimum answer, right? If you look at this, 6 is the answer, right? Let's look at one more, 5 5 5 and 1 1 1. Really sorry for this. I think my stream, yeah, 5 5 5 and 1 1 1, right? 5 5 5 and 1 1 1. So the minimum to this can be, you can place this 5 at this point and it becomes 5 5, and this becomes 1 1 1 and 5, and ultimately sum again is 6, which is minimum, right? So this case will also give a minimum of 6, right? And the first test case, let's look at that as well. 1 3 and 2 2, 1 3 and 2 2. The problem, see, the problem written to you was in a very bad form. The problem ultimately asks you this thing only, right? That you can pick any element, place it any vector, and then give the minimum sum, maximum sum that is possible, right? So you place this 1 to this vector and this becomes 3, the array becomes 1 2 2, and the sum is 3 plus 1, right, which is 4, and that is the maximum sum possible, right? So the problem statement might be clear to you till now, right? Now let me give you a very great idea of how we can solve this, right? My first thought was, what if, let's say we had many vectors, right? Let's say, what if I want to make the sum as large as possible, right? Then you tell me one thing, what if I sort all the elements in this vector? Sort them first. This is my first step. Sort them first, right? Then the array would look something like, let's say this was 1, this was 2, this was 3, this was 4. The array would look something like this, right? Similarly, after sorting the elements in itself, let's sort the whole array, means vector of vector. Let's sort the whole vector of vector thing and then give a final vector to me, right? Now the final vector would look something like, let's say, uh, this had, we are taking a general example, right? 1 2 3 4, the next element would have 5 6 7 8, then again 9 10 11 12, and so on and so forth, right? This is just an example, right? I'm not saying the array would look exactly like this, but this is what we are achieving to get, right? Now what my claim is, why not calculate the second element sum from each of the vector given to us? What I'm trying to say, calculate, I will prove why this is best. Calculate the second smallest element from every array, smallest element from every vector, right? You will say why. Let's say this vector had a smallest of 6, this had a smallest of 10, right? What I'm trying to do is, whatever the minimum value is there in every array, the first element, which is the minimum element of arrays, I will pick this element and try to dump this at this position. Let's say I will try to dump every smallest element from arrays, smallest element from array, each array, each array, to any every index, to any, let's call it any index I, right? What do I mean by this? Let's say we had this element, right? We will pick this element and dump this. Then what will become, this 6 will become the minimum for this, which is greater than 5, right, which will be beneficial for us, right? When we delete this 9, this 10 becomes the smallest element, and then the 10 is greater than 9. See, the sum will increase somehow, right? The overall sum will somehow increase. Like, let's say first, if we, let's see, let me do a give you a case. Let's say, what if we don't delete any element? Then the sum would be 1 plus 5 plus 9. 1 plus 5 plus 9, right? Now what I'm trying to do is I'm trying to delete the pick this first element, as we can pick delete one element from every index only once, right? So we will pick this element, dump this element here. So this will have a 5, this will not have a 5 anymore. I will pick this element will have a 9, and this won't have any 9 anymore. So let's see what is the new sum we got. The new sum is minimum of this, which is still 1, minimum of this increased by 1, which is 6, and 10. So the sum now is 17, and in the earlier case it was 15. See, the sum in this smaller case also has increased by 2. So what I'm trying to convey to you why this is, we can try to dump the smallest element in every index possible. But what if we try to do this? So this brute force, this is a brute force method, right? That you try to pick this one. Let's say this can be done, that this one can be pushed to other elements. Let me not be confusing to you. What I'm trying to say is, you will try to place this element. Let's call this x1, let's call this y1, let's call this z1, right? You will try to place first step, in first step you will try to place y1 in this vector and z1 in this vector, right? Place y1 in and z1 in array 1, right? In second step, what will you do in second step? In second step you will try to place this x1 in this vector and this z1 in this vector. Now you might think that, hey, this is the smallest element possible, right? Why do we want, because this is the smallest vector, so why will we place this element to this place? You might think this. I will answer to that as well. Be a bit patient, right? So in second step, what I'm trying to say is, place x1 and z1 in array 2, right? You will say okay, and in third place you will place x1 and y1 in array 3, right? In array 3, x1 and y1, and out of these you will find the sum, or the maximum sum which is possible after doing these operations, right? But if you try to do so, each element, picking this element and placing that element on the very uh, index I, and then calculating the sum again, right? This will take big O of n, because you will try to traverse on every element, pick the smallest element and try to place it in the desired position I, right? So that will take again big O of n, right? So ultimately this will boil down to big O of n square, right? And if you look at the time constraints of the problem, this this n can go till 10 to the power 5. So big O of n square will lead to a TLE, right? So how are we gonna improve on that thing is the problem statement now. Yes or no? One more doubt which you might have, that hey, you were talking that 1 2 3, let's say 4 5 6 and 7 8 9, right? Why would we think of placing this 1 at this position, right? This is what your doubt was a few minutes ago. Now let me break this doubt with a beautiful example. Let's say this element was 1, and let's say the second element was 1e9, means 10 to the power 9, right? And the third element was 1e9 again, right? Now you tell me one thing, isn't this good that if I take this element and the rest array is 4 5 6, see, this still the array is sorted, because the first element is 1 here, the second element is 4. So the final array will be sorted something like this only, right? 7 8 9, right? Now what I'm trying to say is, if you pick this element up and add this in this vector, isn't this useful to me now? Yes or no? Because now the smallest element in this vector is 1e9, which was initially getting overshadowed because of that smallest value 1, right? So we need to try, we need to try for every index I, right? We need to try for every index I, that we place, that we pick that element and dump it to any other index I, right? But you, if you are with me till now, you might be thinking, hey, but you as of now you told that this will lead to a TLE, because the sum would be the total time complexity will be big of n square. Yes or no? How can we optimize this is the problem statement, right? Let's say we had 1 2 3. Let's go back to the basics. 4 5 6 and 7 8 9, right? Let me, yeah, yes, this is how my array currently looks like, right? Do you notice one pattern? The pattern is, what if you pick this element up and try to dump it here? What will you left with? You will left with the second maximum, right? Let's create a maxi, or let's create a variable called sum. What will this sum hold? This sum will hold the second largest elements of all array, second largest element of all array. You might think, why do we need the second largest element? Think of this smartly. If you want to place this, if you want the sum to be as maximum, you want to go to the rightmost side of every vector. But since you can delete only one element from each vector, the maximum you can go reach is the second element. The maximum in from each vector that you can fetch is the second element of that vector. Yes or no? Am I making sense to you? Similarly, if let's say you remove this 4, right? So removing this 4 will yield you a 5, which is better than 4, right? You remove this 7, the best you can have is 8. You remove this 1, the best you can have is 2, right? So whenever you are trying to remove an element, you will, what you will do, you will think of deleting all the first elements, making means picking all the first elements from every vector and dumping it to any specific one index I. Yes or no? Am I making sense to you? I hope I am making a sense to you, right? So what will happen in this case? Let's try to understand it. So my sum will be nothing but the second value of every index, which is 2, which is 5, which is 8. Means 2 plus 5 plus 8, right? But hey beast, we didn't delete any element till now. I am saying yes, but we know that the maximum sum that we can have is 15, right? As of now, the maximum sum is 15. Yes or no? Now think of this. When you are at this array, what you will say is, what if I want to dump every element in this array? Means this array will contain my 4, this array will contain my 7, and all of those elements, right? If you try to do so, let me, yeah. So what if we try to dump everything at index I? If you try to do so, the initially you had added a sum 2 because you thought that, hey, I will pick this one and throw it somewhere. But according to nature, everything is coming to my array as of our code, right? As of not nature, as of our code, right? So 4 will come, 7 will come, but every element will come to this index and we won't be able to give away from our index. You don't want this number to float anywhere else. Yes or no? Because if you, let's say you pick this one and throw it somewhere, now the objective of having the sum as 5, right? Let's say you throw it here, then the sum which was adding 5 to our answer will now add 1, right? So you will say that, okay, whatever my element was, let it stay there, everything will come and dump in me, right? So my array, the first element will look something like 1 2 3 4 and 7, right? How will the sum change? Look at this beautifully. My sum initially had a 2, which could not be done anymore. So first things first, what you will do, you will say, okay, let's say my value, we are traversing on every index and we are trying to dump every element on that index, right? So if you do so, the dream of having the second element in your sum will shatter somehow. So this value will become sum minus array of second element, which is array of 1. Right? Array of 1 means this array, we are talking about this array. This is array 1, right? This is array 2, right? This is array 3, right? So the sum will be, value will be s minus array of 1. Array of 1 means the first element of the array. Now you can't have 2 in your proper sum, right? Good. If you do so, what is the sum that is getting added to your answer? See, 1 will be added to your answer, whatever the global minimum is, right? Why the global minimum, I will explain that if you, when we will go to I equal to 1. But as of now you are trusting that, yeah, the sum will get 1 will get added instead of this 2. So we first remove that 2 from our answer and add val plus equal to global minimum, right? Global minimum is array of 0 0, right? That is the very first element of the whole final vector, right? Now, when you go to this element and you try to dump everything at this index, look beautifully what happens to this, right? When you try to dump at index 1, right, this 1 will come and this 7 will come. So it becomes 1, 4, 6, 7. And the minimum is 1 from this array. So the dream, now the array becomes 1, 4, 5, 6, 7, right? So the dream which was to have a 4 has been shattered. And now this sum will have the value will have sum minus this element, which is array of 1. Initially we will not add in the vector, we are thinking it initially. See, if you don't have these elements, still the sum will be, the dream was to add a 5, not a 4. So really sorry if you are till with me. The dream was to add a 5, right? But now as we have added 1 and 7, we can't have 5 in our answer. So value becomes s minus array of I of 1 gets subtracted from it, right? And whenever you add all the rest elements in this subarray, right, 1 gets added, 7 gets added. So think of this now, the global minimum, which is the first element of the whole subarray, right, of every subarray, or not subarray, of the array, right, of this array, 1 also gets added to this, right? And somehow 1 will become minimum. So value plus equal to array of 0 comma 0 gets added every time. Why? Because when you see, when you try to dump everything in this third vector, this 1 will also get dumped in this, at this place, right? So instead of adding a 8, we will add 1, because 1 is getting dumped at the place. Yes or no? I hope I have made sense to you. If not, please do drop in the comments which part you didn't understand. I will definitely make sure that I can explain you that in the comments, or any proper thing which I can do from my side. I will help you with that, right? So now we can conclude a final statement. What we can say, we will try to dump every element and my sum can be easily calculated at big O of 1, right? How we are finding? We are finding the total sum initially, total sum, and after the total sum we are subtracting a small element, which is the array of current element I and first element of that array, right? And we are adding a global minimum. Why we are adding a global minimum, beast? The reason is very simple, because if we want to dump everything except everything in a certain vector I, then this 1, which is the smallest element, also gets dumped to this place, right? And that is the reason we will have something like that, right? Now let's look at the code, and after that code we will do a dry run for a test case. So wait for that as well. So yeah, give me a second for that. Yes. So if you look what we have, I have written the code exactly as I have told. So we create a final vector, right? And we are creating the final vector. We are taking every elements from the array and sorting the elements first and then pushing the elements in the final vector, right? So I hope this part is not that much hard. You can pause and read. I will paste the code in the comments as well. You can read from that place as well. This is just creation of the vector final, right? We are sorting the elements inside a vector itself, and then finally we are sorting the final vector which we have, right? We have created a variable called sum, right? Now let's say what there is a edge case which we have not discussed. What if the array had only one element, right? Then there won't be any second element, right? That's it. The all the core logic remains the same. There won't be any second element. That's it, right? So this is what we are doing. If my size is greater than one, then you will always have the second element of the array in your sum. If you don't have the second element in your array, then what you can do? You can do nothing. The first element will be added in your maximum sum, right? Now what we are trying to do is we are trying to dump everything to this index. And how can we do that? We can simply say long minus. What can we minus? That will be the first. Initially I'm doing I of 0. If my size is greater than 1, then my second element will not be added, right? I hope this is clear. Let's say my array had 1 2 3, right? Let me briefly do this. 1 2 3. So if my size is greater than 1, right? So if my dream of adding this 2, if I want everything to be dumped at this index, right? My dream of adding 2 gets shattered, yes or no? Similarly, let's say we had 4 5 6. If we add this 1 to this array, right? 1 to this array, then the dream of having a 5 will get shattered, right? So that is what we have done there, right? But what if we had only 1 here and a 5 here, right? Then you will pick this element and add this at this point, right? There is nothing left at this certain position, right? So this is what I have done here. If my size is greater than 1, I did a minus equal to final of I comma 1, which is the second element of the array. I did a value equal to minus, whatever my minus was, and the value plus equal to final, the global minimum back. We are adding the global minimum back, and we are trying to see whatever the maximum value we can get via every step, right? So this will return a maximum ultimately. So I hope the code was very smooth for you, right? And the time complexity of the problem is big of n, right? Okay, now let's look at a test case so that we can understand 1 2 3 and 4 5 6. This is the case we have been running till now, right? Let's look at this 5 5 5 and 1 1 1, right? 5 5 5 and 1 1 1, right? So first let's calculate the sum. What will be the sum? Go with me. 5 plus 1, which is 6. Initially the sum is 6. Now what I'm trying to do is, let's say I am at I equal to 0, means at this position. What I'm trying to say, how my final vector will look like. Let's first create a final vector. My final vector would look something like this: 1 1 1 and 5 5 5. Yes or no? Now what I'm trying to do is pick this element, every other element we are trying and pushing that element to this vector. Yes or no, right? If I try to do so, the dream of adding this one in my sum gets shattered, right? Because I have added this 5 here, right? I can't remove this 1 from my place, right? So my sum becomes 6 minus 1, right? And I have to add the global minimum back because 1 is still the minimum of this array, right? So plus 1, which is 6, right? Similarly, if you go to I equal to 1, this case was very vague, right? You will try to put this 1 in this array, right? So let's say if I put that 1, how will the sum look like? My sum will become 6 minus, the dream of having this 5 has been shattered, so 6 minus 5 and plus the global minimum, because this, see, the 1 is the minimum for this array, right? So the global minimum gets added back again. So 1 plus 1 is 2, and what is the maximum out of all these? 6 is maximum, so we will return that as our answer, right? So I hope the problem statement was clear to you. The solution, the time complexity of the code was big of n only. So that's it for the video. If you enjoyed it, please do give a subscribe and a like as well, and drop some comments. Do join our Discord channel, and that's it for the video. Thanks for watching.